So welcome to our today's session. So today we are starting with our math practicals, and the session is towards the operations, and we were looking into decimal system. So in the last class, we saw the decimal system material was golden beads. We saw units were represented by a golden bead, tens by a golden bead bar, hundreds by 10 bars stacked together. That makes you 100 square, and 10 such squares making up a cube, which represented the quantity of 1,000. So this is what was the beginning time we started to introduce to children. But any time that you are introducing decimal system, there are two things that we need to keep in mind. Okay, so you can write down later. Two things to keep in mind is like, how does a child read a number? Or when you give the number, how does the child arrange the quantity? These are the two things that we need to do. Say, suppose in case, if I give you a number 3,445. So how do you write 3445, correct? So 3,445. So for every number that I associate, we have two things. What are the two things? We do have a place value and we do have a face value, correct? So in that cases, like say 3,445, if at all, if I'm taking, you need to be able to help me with, is this units or is this thousands? Is this units or is this thousands?
Thousands, ma'am.
Thousands. But most of the children, what they find it is like they say this is 3 units. And they say this is tens, this is hundreds, this is thousands. Especially to the younger ones whom we are introducing conceptuals for all of them. So they have a difficulty. So that's the reason what we do is we usually take up a felt mat. Felt mat is where you have the notations mentioned over here. And you have to first introduce these letters to the children that this is ones, this is tens, this is hundreds, and this is thousands. You go with the quantity, you put a bead here, you put a tens bead bar, you put 100 square, and you put 1,000 here so that the child understands the positions of each of the quantity where it needs to be kept. Now, slowly, when we start to pick up this quantity, what happens is like you got to go really slow to the child. You ask them, can we read the problem statement? Yesterday also, when we were doing the same lesson in the classes, children were getting confused is because the teacher has written all the numbers in black color. One possibility, difficulty for the child to understand. So how do you overcome? You write the numbers according to the color codes. So your thousands are in green, your hundreds are in red, your tens are in blue, and your ones is in green color. So when the teacher writes this, what happens? Even your mat is in the same color. The child will quickly understand. If the teacher says, okay, can we read this number? The child will start saying, ma'am, it's 3,000s, 400s, 4 tens, and 5 ones. That's how they read it initially. We don't make them read like 3,445. We say, how many thousands are there? Can you identify? The child says, ma'am, there are 3,000s. How many hundreds are there? Oh, yeah, we have 400s here. How many tens, children? Yes, ma'am, we have 4 tens. These are some of the questions you got to give them. If the child is not ready to identify through the label card, through this, you cannot start doing operations. When I say operations, don't start with addition, subtraction, multiplication, division. If your child is not able to read the problem statement and identify where to place it. So positional values are very important. So every number will have its place value and its face value. So what is the place value of number 5 here? What is the place value? Where should I place it? Should I place it in thousands position? No. Should I place it in hundreds? No. Should I place it in tens? No. So should I place it in ones? Yes. So the place value of number 5 is ones place. But what is the face value? The number 5 itself. Now, if I say for 4, the face value is 4, but the place value is the tens position. For hundreds, the face value is 400 and the place value is the hundreds place. So this is one differentiation that we give it for children. Why do we introduce this? If you say 300, possible chances for the child is to write 300 here instead of 3. This is one of the errors that we will have to be identifying and going through that. Okay. So now what we do is like we use another material to help our children perform on 4 operations. Please note down the name of the material is called stamp game. Just like your golden beads, we use the same number to help our children work on decimal system. Correct? Is everybody there? We work on decimal system. We want children to work on the decimal system. So we use that material because golden beads consumes a lot of space. And we don't want the children to take up the space when they're actually working on the working mat. So we go for an extensive material, right? So how does the stamp game look like? Now, one differences of my golden bead was like the quantities was increasing. The size of the material was increasing. But in stamps, you will notice everything is going to be of the same size. Like my unit stamp is going to be the same size. My 1000 stamp is also going to be of the same size. And I would have 1000 written on this in the green color. And my ones, 1 is written here. Correct? Now, what about my hundreds? I would have a same size stamp and I would have my 100 written on this. And for my tens, I would have the same size stamp and I would have my 10 written on this. So the size of every stamp is the same stamp size. But in the symbol cards, what we noticed was like the size was increasing. For example, the tens card occupied 2-digit space. What about my ones card? It occupied a 1-digit space only. And my hundreds cards occupied a 3-digit space wherein I could easily accommodate 3 numbers. And my thousands card occupied a 4-digit space. 1, 0, 0, 0. Now see the difference? So the materials are also becoming tinier and tinier because the child is now aware about it. So you don't have to print these ones. Now even this comes with different sizes. You can go for a large size material, medium size material or a small size material depending on your budget. Okay, depending upon the school's budget, you can choose. Okay, so this is one of the differences. Now moving back to what all can I do with my stamp game? I would still do my addition, subtraction, multiplication and division. What are my prerequisite as a teacher? I need to have my prepared cards or I call them as my problem statements. Correct? As teachers, I should already have my problem statement ready. I keep my problem statement ready. I need to have a mat and the name of the mat is felt mat. And then I start. Okay, how does the material look like is the next question. To begin with, how does the material look like? We go with the introductory part of it. Okay, so let's see how does the material look. As I mentioned, the name of the material is stamp game and it comes into your what? It comes into our decimal system lessons. Now to begin the lessons, what as teachers I need to have, as I gave you the prerequisite of all my materials, I would use my material. Okay. So the material of the stamp game, along with that, I would give also, what do I give? I would also give my problem statements. So you keep your problem statements, that becomes easy for me. Now can you see the 1 stamps? It's so nice. So the problem statement for me was 23 plus 15. So my responsibility is to connect the first number first. So 3 ones, 2 tens. So did I collect the first number? Yes. So 23 has been collected. Now I will collect the next quantity. That's my 15. So I will have to take 5 ones and then how many tens? I collected 5 ones and 1 10 is what I need to be taking it up with. So we do that thing. That is so good. And moving thing from here, you add all of them, you join all of them. Once you join, you got to count. Okay, so we got the answer as 38. So was this a static addition or was that a dynamic addition?
Static addition.
Static. We did not have any carry forward. Now let's do a dynamic one. Okay, so note down the problem statement. The next one, what we are doing is 47 plus 88. 47 plus 88. Now you will see you will have a carry forward. So what is the first rule? We only arrange the first number. So 4 tens and 7 ones. The child will also start to pick 7 ones. And from there, I add my 4 tens. 7 ones in the ones position, 4 tens in the second position. Now I got to add my other number. That's my 88. So 8 ones and
8 tens.
how many tens? 8 tens.
8.
Look at the long growing line. Look at the long growing ones.
Yes.
So be patient. Pick only one by one. Join the numbers and start counting. Now the rule here is like in dynamic. Anytime that you hear 110, anytime you hear 10, you got to replace the 10 with 110. Okay, so we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10 ones. So 10 ones, you got to replace that with 110. But where do I keep that? I have to keep it in the blue, and whatever I replace, it will go back to the tray. Now you write how many remaining ones are there. So remaining ones are only 5. Do the same counting for your tens. 1, 2, 3, 10, 3, 10, 4, 10, 5, 10 until 10 tens. So 10 tens is making up 100. So 100. We replace it with 100. So 100 goes to its hundreds place. So what is remaining? My 3 tens are remaining. Yes. So my final answer is 135. We have 100s, 3 tens and 5 ones, which is being there as a part. So this helps us to learn both static and dynamic. We just did a 2-digit addition because it would be a little time consuming shuffling all of that. But you can do a 3-digit and a 4-digit addition of both static and dynamic using the stamp kit.
Ma'am, can you repeat the rule one more time?
Purni?
Yeah, can you repeat the rule one more time? What is the rule of this one?
Rule, okay.
Any...
Let me explain it to you in that. You go back here to your notes. Okay, so we have your ones, right? So you have your ones. You have your 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Maybe likely 11 and 12 and 13. So you had 13 ones.
Okay.
Now you start counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means 10 ones are making what? It's making 110.
Okay.
How do I represent 110 in my stamp game?
110.
It will have a stamp which is like this. Correct? So I would replace my 10 tens by 110. But is this place value to be kept here? No. So that's the reason I keep it in my tens position. I add it here. Now, whatever my problem statement, I already had some tens here. I already had some tens. Now I count with that also. Maybe it is more than that. Maybe say it is 15 tens. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 tens, I will take it, keep it aside, and I would replace that with 100 because 10 tens are equivalent to 100. But I can't keep it here in the blue section because of its place. So I keep it in my 100 section and I would continue. Anytime you hear 10 tens, 10 hundreds, 10,000, we do a replacement. This is for carry forward. Now, what if you have subtraction? What if you have subtraction? Say, suppose if you have, say, 43 minus 27. If this is your number. So we are only good enough to keep how many tens? 4 tens, right? So 110, 210, 310 and 410. But how many ones can I keep? It is 3. 1, 2 and 3. But out of this 3 ones, how many should I be taking away? I have to be taking away 7. But do I have 7 ones here? In my tens and ones, do I have 7 ones here? No, I don't have. So what do? I have to borrow. Now, where do I borrow? I borrow it from my tens place. So when this comes here, can I keep the blue one here? No. So what do? I do a replacement of this. So what I do is like I take from my extra stamps and I would replace it. 5, 6, 7, 8, 9, 10. Usually we keep it vertical. Since I have no space, I'm doing it horizontal. So this is taken away. Okay, so you have to take away. So you have to take a tray. And this blue color has to go back into that tray. So we have taken this and we have
Got it. Okay.
replaced it with this. Now say how many you have. 1, 2, 3, so many ones you have. Now you take away 7. 1, 2, 3, 4, 5, 6, 7. You took away all that 7. So that 7 came back here into the tray. How many are remaining? We have 6. Immediately come and write the answer. Now come back to the next one. We don't have to look into this number. We only have 3 because 1 is already taken. So we have 3 tens. How much you have to be taking away? 2 tens.
2.
So 110, 210 goes back where? Into this tray. So 110 and 210 goes back into the tray. So the remaining is what? Nothing is there.
1.
Sorry, one more is there.
1
so we
is
have
there.
110 is remaining. So the answer is 16. So this becomes your dynamic subtraction using a stamp game. If you're doing it with the material, it becomes even more easier for all of us to understand. Let's see the dynamic addition also. Now here is what we go with the dynamic addition. Sorry, dynamic subtraction. Always, as I mentioned, you got to have your problem statement. So what's our problem statement? We are doing a 4-digit now. So note down everybody. So the problem statement for us, it is 5,428 minus 1,216. Now tell me, is it static or dynamic? It is
Dynamic.
It is static or dynamic?
It is static.
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 Static. No carry forward, no borrowing, nothing is there. So it is static. Very simple. So I have to arrange only my first number. So what I do, I tell to children to arrange and identify how many ones are there in the first number. 8 ones. So we take 8 ones. How many tens? 2 tens. So we take 2 tens, 1 10 and 2 10. How many hundreds? 4 hundreds, 100, 200, 300, 400. And how many thousands? 5 thousands. So 1,000, 2,000, 3,000, 4,000 and 5,000. Now our first number is all ready. Now we got to take away the second number from the first. You always encourage the children to start from the units. Only from the units. So children can't start from thousands. They do that mistake. So yesterday also we did so many times, but children got confused. So you go a little slower and always tell them these rules. No matter you think they might have understood, but as teachers, you got to make it a rule and ask them multiple times, which is the first number that we do. There could be a set of students who don't know, or they would have forgotten, right? So always ask children. So make it a rule that, children, which number are we taking it up? It's from ones. How many ones? I have to take, maybe ma'am, 6. So 6 ones is what we need to take away. So we remove that, put it into a tray. Next, we have 2 tens, and you need to take away how many tens? 1 10. So we took away 1 10. So what was remaining? Only 1 10. So you write the answer as 1. Now you have 4 hundreds. You have to take away 2 hundreds. So the remaining is 200.
2.
So you write that. Now you have 5,000. You got to remove 1,000.
1.
We removed 1,000. So what is remaining? We have 4,000, which is remaining. So your answer becomes 4,212. So this is your pure 4-digit static subtraction. Now what we do, look at this problem statement. 2,345 minus 1,683. Now you tell me, is this static or dynamic?
Dynamic, ma'am.
Dynamic. Why is it dynamic? Because you would
Borrowing.
borrow. You would be borrowing. Correct. So we do that borrowing. So initially, let's arrange the first number. 5 ones, 4 tens, 300s, and 2000s. First number is arranged. Now, from the 5 ones, we have to take away 3 ones. Let's start to take away 3 ones. We remove it. Now, from 4 tens, you have to remove or take away 8 tens. Is it possible? Can you take away 8? Not possible. So, what do? You borrow from the next one. So, when you borrow, you got to replace. What makes 100? 10 tens make 100. Since you borrowed, it has to go back to the tray. So we have all these numbers. Now you have such a long one. Now you remove your 8 tens. So remaining becomes your 6 tens. Now you have 2 hundreds only, but you have to remove how many hundreds? 6 hundreds. So I don't have. So what do? I have to borrow from thousands place. So let's borrow 1000. So I have to replace that. See, each time you borrow, you have to remove it and put it back into the tray. That green has to go back in the tray because you replace the quantity here. If you don't replace and keep it, your problem will become wrong. Now you answer what it is. So we don't have anything. When there is 0, you have to replace that with a coin. Or you have some coins there, depending on the quantity. Is it in the thousands place, 100 place? Depending on that, you take the color and you keep. So 0 means nothing. So the answer is 0662. So 0 means nothing. So your final answer is 662 because we don't have anything in the thousands place. That covers your dynamic and static addition, subtraction using your stamp game. Any doubts in these two exercises? It's pretty clear. Now we do to the next operation. So that is your multiplication. So can I do multiplication using the stamp game? Definitely yes, we can do it. But it is like a added addition. You can either do vertical addition or you can do horizontal one. How do we do that? Okay, let's take a look and start working with our multiplication. So as I mentioned, the first rule for all the teachers is to give a problem statement. So we are doing 2342 into 3. So how does we tell to children? What is the multiplier here? What is the multiplier here? Number 3 is your multiplier. Yeah. 2342 is your multiplicand. So 2342 has to be how many times? 3 times. So let's identify this number and we have to collect the quantity. 2000s. So I'm going to keep the skittle because we need to multiply 3 times, right? So we are putting that as a multiplier. So 3 skittles we have to place it. So let's identify what is the ones that we have. So it is 2 ones. Then I have to take 4 tens. I'm taking the quantity, 4 tens. Then 3 hundreds and 2000s. This is the first quantity, 2342. Everybody agrees on that? Even if it is put vertically, you all understood? 2341. There could be another way that you would arrange, not vertical if you don't want, if you feel it's confusing for you in vertical. What you can always do is you can go horizontal also. So what do we do in horizontal? So we have 2000. Then we have how much? 300. Oh? 300. What is the next number?
42.
42. So 10, 20, 30, 40, and then 2. So this, so your skittle will be where? Your skittle is like this now. It's horizontal like this. Now second time, then the third time.
3.
Okay, so again, it's the second time, it is 2000. 300 and 40.
300.
It is 300. Oh?
300. 342.
And that is 1000, ma'am.
Yeah, that is 1000 only. Sorry, this is 1000. This is 100, tens and ones. Quantity is correct?
But 2000, no?
2342.
2000.
Okay. So it is not 3000. It is 2300.
1042.
In hundreds also.
No, my tool it's not picking the color. Perfect? Okay. So I think I have to add one more blue. Okay. So in your practical paper, you will also draw. So get used to drawing because as teachers, you will also draw on the board. So you have to get used to drawing too. So we arrange this. So this is 2000. Sorry, this is 2342. One time, 2342. Two times, 3000. 2342 three times. We arrange the quantity. Now what do? You join them and you start adding. 1, 2, 3, 4, 5, 6. So 6 ones. Now 110, 210, 310, 410, 510, 610, 710, 810, 910, 10 tens. So when 10 tens are together, what do we do? What do we do? You have to replace that with 100, correct?
100.
So I'm replacing that with 100. So when I replace that with 100, I will have to be removing all of this, correct? So I replaced all of that. So how many tens are remaining? Two tens are remaining, correct? So I would have my 2 tens are remaining. Now count the hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 10 hundreds. So the moment that you hear 10 hundreds, it can't be there here. You need to have a replacement. So 10 hundreds is replaced by what? 1000.
1000.
So when everything moves, what happens? I will not have anything here because I moved everything there. So do I have anything in my hundreds place? Nothing.
No.
So what do? I write 0 here. So nothing is there in my hundreds place. Now count your thousands place. 1000, 2000, 3000, 4000, 5000, 6000, 7000. So my answer is 7026. This becomes my answer. So what we did here is multiplication you can do as added addition. It is nothing but added addition only. You will only arrange how many times. So you should always arrange depending upon what is your multiplier. It is multiplied by how many times. That many times is what you need to take and you need to multiply accordingly. Clear everyone? This is very simple. This is how you would write in your answer sheet also when you're doing a presentation. The writing module should also be written in the same way. Pretty simple it is. Now when you go back and see this particular video, it makes it more easier for you. Now what are we doing here? We are doing vertical addition here. So first time we did 2342 here. Now for the second time, second number, we would again arrange the same. So you would have the same number of ones, same number of tens, 3 hundreds and 2 thousands. And similarly, you have for your third one. Now what would you do? Next is like you will add all your thousands. Correct? So you begin with what? You begin with your units. So your quantity is collected. See now, we started grouping everything together. These are the ones, these are the thousands, and these are the hundreds. Now see, it's becoming easy. Now we sorted. But what we did in the drawing, we began with this. But in the actual practicality, you would do this way. And then you add how many numbers are there. 400, 500, 600, 700, 800, 900, 1000. So you replace all your 1000s with 1000. Do I have anything in the zeros place? Nothing. So that's the reason I would put a coin there. Since it's in the hundreds place, I would put a red coin. In the previous exercise, since it was 0 in the thousands place, I choose a blue coin. Okay, so you would have a lot of coins also to put that zero value. So your answer is 7,026 becomes your answer. Easy, everybody? So we had a carry forward also in this particular exercise. So this helps you to work on your multiplication part of it. A very simple exercise, very easy one to actually go for it. Now let's quickly disconnect and connect back for the division.